All right. I hate to ask this question because last week was such a, I don't want to say waste, but goodness gracious, it was so hectic. I know we got the syllabus covered, right? Did we get the research paper covered? Right. Probably didn't go over my locator card, but it's out there and you can see it. If you have any questions, you can ask. Did we talk about safety? Yes, all three kinds. Yes, okay, good. So did we even get started on math though? No. Okay, so that's where we're starting today. Good news, folks. Okay, and I told you earlier I'm using a package called Screencast-O-Matic. We are recording now. Before we actually get started today, though, on this, let me go over a couple of things just to bring you up to date. Now, I talked about some of this before some of you came in, so the rest of you, most of you have heard parts of it before. But I did finally get the syllabus completely, hopefully, updated, corrected. I hope I found all the errors in it and stuff, and it's out there. Now, earlier, I think I told you I was putting it under course content and more, no, course handouts and more. Actually, on the new Blackboard, near the top of that column, when you get to the course and you have those blue tabs that goes forever, near the top there's one that says syllabus. So I put the syllabus under syllabus. Okay? So that's the tab. You'll find that. Can I get your name, please? Jayla? Okay. And Gibron?
Yes, sir.
Huh?
Yes, sir.
Is that right? Okay. All right. Jayla? Collier, right? Okay. And did I pronounce your name right? Gibron? Which?
Yes, sir.
Which one? Hard G or soft G? Gibron? Gibron. Okay. Accent on the last syllable. Okay. All right. I probably still botched it, but anyway. Okay. So, the syllabus is out there in Blackboard under that tab. It says syllabus and something, but anyway, course information, syllabus, or something like that, under syllabus. And then just a couple tabs, maybe the next one or another one, two down, it says instructor information and schedule or something like that. And this looks like Gary Melton, if I'm not mistaken, is it? All right. Okay. And you still go by Gary? Okay. Oops. All right. Good deal. And now we're down to, can I get your name, please? Second. Oh, I got it. If I can find you. Fields, there you are. Yeah, but I got you over here too. Just to show you before. And you say Latasia. Is that right? Mm-hmm. Okay. I know I asked you all this before, but S is sort of silent. Okay. Latasia. Okay. Now, is there a seat available, anybody? All right. One more comes in. Well, I guess we can get one more here. After that, we find a new room, okay? We were limited to 30, and there are 30 seats in here, but evidently they've added a couple since that. So, let me start over for you folks who have, this is your first day, okay? Everything we've done so far is out there on YouTube. The bad news is that I don't have the link set up yet, but it's out there. And soon, hopefully today maybe, I'll get that link set up. Okay? So, you can go back and see what happened the first day, last Monday, which was a very short day because I was chasing all over the place, helping classes find the room, helping classes move rooms, helping students find rooms. It was first day of class. Okay? And then even Wednesday was still more of the same. Okay? But anyway, you'll be able to see and hear everything we talked about. Okay? And that will be on YouTube videos, and it'll be through Blackboard. So I'm getting to that in just a minute, so I'll tell you where to go in Blackboard in just a minute. Let me go back and say Blackboard, okay? When you go to this page for this class on Blackboard, there's a whole series of blue tabs on that home page. Near the top, maybe not right at the top, but near the top is one that says something about the syllabus. That's where I put the syllabus. It's out there, hopefully corrected, everything there. Okay? Then, just shortly down from there, maybe the next tab or 2 or 3 later, somewhere there, you'll see one that says instructor information and office hours or something like that. Okay? On that one, I put my locator card, showing when I'm on campus, when I'm off campus, when I'm in class, when I'm out of class, when I'm at lunch, all that kind of stuff. Every day of the week. Okay? Now, you have to go quite a bit further down, but before you scroll to the next page, I think you'll find class handouts and more. On that one, if you click on it, what you'll see right now is the research paper instruction. Okay? And so you can read that. Okay? Then I think the next thing I have in there is a bunch of PowerPoints. And because this book, I've never had a book, this is the first time I've taught from this book, never taught from a book that has as many different PowerPoint presentations as this one does. It has like 3 or 4 PowerPoint slides and then it does a new presentation. So I had to load one at a time because the Blackboard, that's the only way you can do it. One at a time, and I got chapter 10, chapter 11, chapter 12. I got somewhere maybe in the 13 when I just ran out of steam last night. I mean, I was going bonkers. It's such exciting stuff to do. I don't see how I got bored with it. But anyway, I quit after a while. I'll get those finished sometime too. Now, other things that are not there, okay, but they will be there soon. I will put some links to websites that either I have found or other students have found over the years that they found helpful for the course. There's not that many, but there's a few. I think one is Prof. Rob Bob. I don't know who liked him, but somebody liked him. I don't think I have Khan Academy there, though I've heard several students say they like Khan Academy, but there's several others. And so I'll put those out there. And then the last thing that'll be under that one will be YouTube. It'll say Math 100 YouTube videos. It's not there now, but when it is, you can click on that and you go to the YouTube video. And it's called the playlist. Okay. Now let me talk a little bit about that playlist. I don't delete that every term and start afresh from the School of Hard Knocks. I found not to do that because occasionally we'll come in and the server will be down. And if the server's down, I can't record that lecture that day. Okay? So you'd have a void there. Okay? We had one day in the last couple of terms when the administration forgot to renew the contract with Screencast-O-Matic, so they weren't there. Okay? And then there's been other things. The supercomputer could go down or have maintenance or something like that. So any of these reasons would keep me from being able to record. So I'll leave all the old files up there, and then as I do new ones, I delete the old ones. So the new files are always at the bottom. So you'll see syllabus, you'll see research. Okay, those are the new we did last week. And then, now it's a new book, different book and everything, so I'll try to do it thematically, delete the ones, but that's not going to be very easy. I'll just probably take off one for every one that we do. Okay? So the new stuff is going to be at the bottom, the old stuff at the top. You can look at the old stuff if you want to, but the new stuff is what's important. Okay, I think that's it. Any questions on how to access the course? It's not totally set up yet, but it's pretty far along. All right. This book also doesn't have chapters. It has modules, okay? So module 10 is where we're starting with polynomials. I think we talked about this before. I'm sort of a cynic when it comes to some things with education. I shouldn't say that. But I remember when I was in junior high. Later, they became middle schools. That was a step up. And then sometime later, they went back to being junior high because that was a step up. And then sometime later, they called them middle schools. And yeah, I don't know why they changed the name. So rather than a chapter, we have modules because you learn it a lot better if it's in modules than in chapters, right? Yes, okay. So this chapter is module is Polynomials. What in the world is a polynomial? Anyone tell me? Okay, let's break it down. Split it here. We have a poly and we have a nomial. Any idea what either of those means? Poly means multiple, many, absolutely, many. And then nomials, the best I can get out of that is names, though they're not really names. They're really terms. Poly terms, many terms. Now here's the weird thing about math, or at least with polynomials. A polynomial can have only one term. Can have. So one is many, okay? Two or more, it could have 15. It could have 25. But many terms. Many terms. Okay? Now, first thing we're going to start with is addition and subtraction of polynomials before we even define what they are. So let's go with that. And the objective 10A, and again, this is my first time teaching from this, and this book is has all these slides on nothing but little words on it. We will add polynomials. All right. Now, starting over. Remember I said, what's the fewest number of terms for a polynomial? One. Okay, and that's called a monomial. Okay, does anyone know what a monocle is? Okay, monocle. Yes, one of the lens. You know the Peanuts guy on the Mr. Peanuts or something like that. He has it on the monocle. Yeah. I think in terms of food, people. I'm sorry. Okay, so a monomial is a single term polynomial. It can be a number. It could be a variable. It could be a product of numbers and variables. And it could even be a combination if you're dividing by number. Okay? Like this. Okay? So, a single number, 7. That can be a monomial, a polynomial. A single variable, b or x or whatever you want the variable to be. It could be any number, 2/3, fractions. Yes, of course it could be. It could be written as 2a over 3 or 2/3 a. That is a monomial. Okay? Even though there is a division in there, remember the division has to be a number only. Okay? Or it could be a number and more than one variable. And by the way, these variables could be raised to many powers. Okay? That's a monomial. Okay? Any product, quotient of numbers, as long as the number is not zero. Why not? You can never divide by 0, so don't ever do it. Okay? You can divide by any number in the world except 0. So don't do it. So you can divide by 3, divide by 12, divide by 4,585,816 and a third. You know, divide by any number you want to, but just don't divide by 0. So any combination of numbers, variables, powers, as long as those powers. Now here's a key. Here is a key. The powers can only be, the exponents can only be positive whole numbers. You can't have negatives. You can't have fractions as you're done. You can have fractions here. You can't have fractions there. Okay? You can have decimals here. You can't have decimals there. You can have negatives here. You can't have negatives there. The exponents can only be positive whole numbers. Coefficients, any number. Any number. Fractions, decimals, rational, irrational. Okay? Now, the variable can't be irrational. The number can be. Square root of 3x, perfectly fine. Okay? X times 3 times the square root of x, not a monomial, not a polynomial. And here's why. The exponent, what is the exponent for this x? Nope. Okay, yeah, under here it's 1. It's 1/2. When you have a radical written in exponential form, whatever the index of the radical is the denominator of that exponent. And since you don't see a index here, what do we assume it is? Yeah, you assume the index is 2. That's the only place in math that happens that I know of. If you don't see a variable here, a coefficient here, you assume it's 1. No, not 0. 0 make that number 0. But if you don't see a coefficient, you assume it's 1. If you don't see an exponent, you assume it's 1. If you don't see an index, you assume it's 2. Okay. The index would be 2. That goes in the denominator here. That'd be x to the 1/2. Because x cannot be written as a product of variables. Square root of x can. Okay, fine. The expression, okay, how about this one? 2x over y squared. Is that a monomial? Not quite. How would you write this as an exponent, but not in the denominator? If you move the y upstairs, what does that become? Y to the -2. Remember, those can be, they have to be positive whole numbers. No fractions, the exponent, and no negatives. That would be y to the -2. Out of the picture, can't happen. X is fine, the y in the denominator can't be there. Only thing in the denominator can be numbers. Except, what number can't be there? 0. Good, okay. So, it's a quotient of variables, not a product of variables. Okay. You can have a quotient of numbers, but not a quotient of variables. Does that make sense? Okay, and by the way, all these rules for monomials, what was the nomial part? What did I say that stood for? Term. Every one of these rules applies to a term for a polynomial. Every term in the polynomial has to be an acceptable monomial. Okay, in other words, it can have numbers, variables, products of numbers and variables, quotients of numbers with products of variables, but not quotients of variables, and not radicals. Okay, good deal. So a polynomial is a variable expression in which the terms are monomials. So the terms, monomials, those are the same definitions. Polynomial of one term is a monomial. If it has 2 terms, we call it a binomial, 3 terms, trinomial. After that, we just say 4 terms, 5 terms, 6 terms. We don't do quadnomials, quintinomials, sexnomials. We don't even want to think about that. Okay, never mind. Okay, so we just go with the prefixes. After that, we just say how many terms. All right, okay to have a -7 there? Sure, and the coefficient, yeah, you can have plus or minus, okay? How about if that was a -2? No, wouldn't work, okay? This is a binomial, 4x plus 2, that's perfectly fine. This is a trinomial, 7x squared plus 5x minus 7. Any questions then on what makes a polynomial? Many terms, the terms can be numbers, variables, and powers. As long as the powers are positive whole numbers and there's no, and you can divide by numbers but not by variables. Okay. So far we haven't added a thing, have we? Okay. So this is adding polynomials. The terms of a polynomial in one variable are usually arranged so that the variables decrease from left to right. In certain cases, that's going to be absolutely necessary. Other cases, it's not really going to matter too much, but we call this descending order, and we call this standard form. So you look at your exponents. 4, 3, 2, 1, 0, blast off, okay? That's how we do standard descending order of the powers. Okay. Now later we're going to talk, probably in the next slide, we're going to talk about special ones of these. Which one do you think is the most special one of those powers? Say again? The 4. In fact, the 4 makes it, we say this polynomial is of degree 4. The maximum exponent identifies the degree of that polynomial. Now that's in single variable. So terms of polynomial with one variable, that's the case. If you had 2 or more variables, you add their exponents together. Not doing that yet. We're just doing single variable for now. In fact, most of the time that's what we're going to deal with. Okay? So, I was psychic. Okay, I looked ahead and saw this was the next term. The degree of a polynomial in one variable is the value of the largest exponent on that variable. Okay? So how about this one? The degree of 4x cubed minus 3x squared plus 6x minus 1. What's the degree? 3. Very good. They have it in blue. Okay. Is that in standard form? Descending order of the power. Yes, it is. Perfectly fine. How about this one? What's the degree of that? 4. Very good. And it's in descending power. How about this one? What's the degree of 7? It would have to x to the first power. This doesn't have an x. 0. Its degree would be 0. Very good. Because what is x to the 0th power? X to the 0th power. 1. Exactly. What's 4,584,816 2/3 to the 0th power? 1. Anything to the 0th power is 1. Okay? Except you can't do 0 to the 0th power. So don't even try. Okay? So anytime you don't see in variable, then that's x to the 0th power, because x to the 0th is 1. 7 times 1 is 7. So yes, the degree of that is 0. Does that make sense? Okay. Degree of a constant is 0. Now, the number 0 has no degree. Okay, it's dead. No temperature at all. Okay. So, polynomials, hey, we're going to finally add a polynomial. Can be added using either a vertical or horizontal format by combining like terms. Most things I like to do horizontally, but adding polynomials, I think I prefer vertical. Okay? I don't like to stand up that much. But let's try it. So let's add 2x squared plus x minus 1. Add to that 3x cubed plus 4x squared minus 5. Now it says use a vertical format. Okay. Now for those who were here, I probably have already mentioned this before, but those that are new, and by the way, the screencast-o-matic, I didn't go into detail here. What it is doing is recording everything I say, or at least that can be picked up by the microphone on my computer. And with me talking so loud, mostly because I'm hard of hearing, I think it catches most of it. And everything that's projected on the board. Now, what it doesn't catch is my arm waving. You don't see that on the YouTube videos. All you see is what's projected on the board and what I say. Okay? Now, because of that, I have a tablet PC that has one of these ionizing pens. Have you ever checked out of Home Depot and signed, the little pad there with these? You know how pretty they are. You know how accurate that is of your signature, right? Oh, this is a little better than that, so let's try it. Okay? So let's add, let me get my pen color fixed. Okay? 2x squared plus x minus 1, and add to that 3x cubed plus 4x squared minus 5. Now notice what I did. I was very selective in how I vertically put these in place. Because what is the only thing you can add? Like terms, or sometimes called similar terms. And is 2x squared similar to any term over there? 4x squared. So that's why I put those together. Is x similar to any term over there? No. So that's why I put nothing under that. Is minus 1 similar to any term over there? Yes, minus 5, so I put that. Is 3x cubed similar to any term over here? No, so I put it out here. And I kept them in descending order of powers. So this is how you do it vertically. Takes a little planning ahead, but you can do it. So how would we add those? Pretty tough, isn't it? What do you get? 3x cubed, say again, plus 6x squared, plus x, minus 6. Done. Y'all are good. We don't even need to do this, do we? Okay? I wish we didn't. Okay. All right. Let's clear this out of the way. Okay, now, if everybody knows this, we can move a little faster. If this is a good review, let me know. It is a good review. Okay, good. All right. All right, so let me erase the ink here. I don't know why I'm up. Okay, and this is what they showed. Ah, look at that. They copied me, didn't they? Okay, they put the top one in and then filled this one in these places. Now, when you're doing that, if this one was missing any terms, count down to X, 1, 2, 1, 0. If it's missing something, then leave a space for that something. Just like they left the space for the X here. Okay, but it wasn't missing anything except the X cubed, so I left space at the beginning. So arrange the terms on each polynomial in descending order, like terms in the same column, and then add them. And it's pretty simple to do. And they got it right, good for them. Okay? Any questions? It's a pretty old hat, isn't it? Okay, sorry about that. Whoa, and that's the end. Because you said that, that ended the slideshow. See? No, I'm just kidding. Okay. And he believed me. Okay. But like I told you before, I've never seen a book that had this short of slideshows. Okay. So we're going to end that and go to 10.1b. Notice I had to type in each one of these individually. And I just got sick. I got, look at this one. 5 slides. All that's there. What a waste. I don't know why they do this. Okay. It took me longer to type than it would have. Well, okay. We're still in one of these, is the same as before. Module 10, polynomials. And 10.1, exactly the same, addition and subtraction of polynomials. And objective 10.1b, subtracting polynomials. Anyone might want to make a guess of how you subtract polynomials? Say again? Okay. You always keep the top one the way it was. And then change the signs of the bottom one, the second one, and go from there. Okay? And then add. Okay? How do you shoot a blue elephant? With a blue elephant gun. That's a very good idea. How do you shoot a red elephant? Not with a red elephant gun. Don't buy a new gun. You swing them around by the trunk until they turn blue, and then use the gun you already got. Okay? So, don't go and create some new thing. Just fix the situation and then add. Same here. Rather than coming up with new rules for subtraction, just change the signs of the second one and then add using the same rules we did before. Don't buy a new gun. Okay, I'm sorry. We don't do guns. Okay. All right. So subtracting polynomials. A few definitions first. What's the opposite of that polynomial right there? Say again? You may say it right. Negative x squared plus 2x minus 3. You're reading my hand, aren't you? Yes. Well, you could put the minus sign in front, or you could distribute the minus sign across. And you were reading back, weren't you? Okay. All right. No, you knew what it was. So the opposite of a polynomial is a polynomial with the sign of the coefficient of every term changed. Okay? Polynomials can be subtracted either using a vertical or horizontal format, and it really doesn't matter. And by the way, with addition, they didn't show you the horizontal format. It's pretty easy too, okay? And to subtract, add the opposite of the second number. Subtract. Okay. I really don't like they say the second polynomial. I'll show you why in a minute. But anyway, you know what they're saying, okay? So let's see. When they write it this way, it is the second one, okay? Now, actually, I'm going to do this both ways. Since they skipped on the horizontal before, I thought they were going to come back and do it. This is my first time teaching using these PowerPoints, so I thought they were going to do it. They didn't. Here's how I would do this one. And you don't have to do it this way. Do it any way that makes sense to you. I would write the first down, and this time I have to go back and change my colors again because we went to a new slide set. Minus 3x squared minus 7. Now, if you're doing it horizontally, what I would do is distribute the minus sign into the second term. Right? That would become what? Say again? Plus 8x squared minus 3x plus 4. And now combine like terms. Here's an x squared, there's an x squared. Those add to be
Minus 3 plus 8, 5x squared. Then find an x term. Only got one, minus 3x. Now find your constant terms. What does that become? Minus 3. Perfect. Okay? Now that's how you could have added the polynomials also horizontally. It's just combine like terms. Just like we did here, because that's all we did, combining like terms. Picking out the maximum exponent and going down, descending order of powers. Okay? Now, it says use a vertical format. So here's how you do it in a vertical format. To me, this is almost harder in this case. Okay? But you can do it. Vertical format. Minus 3x squared. Now remember the little rule I sort of popped in on you before? If you're missing a term, yes sir. Yeah. I'm sorry? What?
I do not have a classroom to teach in today.
Well, where was it listed as?
154. But I talked to the police officer that's reserved for like.
Oh, goodness, yeah, that's not the room. Across the hall from there is 151. Is that being used?
All that is like reserved for like the Mr. Kelly or whoever.
Okay. What time did your class start? 8:30 this morning?
9:30.
Oh, 9:30?
Yes.
Okay. Did you check the number 30? No problem. Sorry. Kind of a new adjunct instructor and hasn't talked to this campus very much. And they put him. Somebody, I think I told y'all early in the term, like that first day, everything has changed this term. The developmental math has changed. This Math 100 has changed. The e-books have changed. Everything. The books themselves have changed. And the people who were accommodating those changes just randomly picked rooms and assigned. What they assigned his class to at 9:30 is a computer hardware room where they have pieces of computer light everywhere, and they put a math class in there. I don't even think they have a board to write on. I mean, they just do hardware in it. Yeah. So so I'm glad he came and told me, but I just didn't want to take time to do it. Okay. Now, like I said before, if you're missing a term, allow room for it. So skip a place for the x term and go over here to minus 7. Since you're doing it vertically. That's why, to me, vertical is a little more difficult in this case. And then we're doing now. The rule is when you're subtracting polynomials, change the sign, just like we did before, change the sign of the second term, that term, okay? So that would be a plus 8x squared. Help me. Minus 3x plus 4, and it's just like we did before. I didn't mean to roll that through it. Combine like terms, and what do you get? 5x squared minus 3x. Second? Minus 3. Perfect. Okay. Pretty simple, right? Make sense? Any question? Now, if you have questions, even I'm saying it's pretty simple. If you have a question, ask the question, okay? I was in the U.S. Navy, and they're not absolutely great at their schools. They have lots of naval schools, but in every Navy school class that I ever was in, I believe, they must have this as a mantra. Every instructor always said, there is no such thing as a dumb question, except there is one. And that's a question you have and you don't ask it. That's dumb, okay? That is really dumb. So if you have a question, ask it. As soon as you ask it, it's no longer a dumb question. If you don't ask it, that's dumb not to ask, okay? So let's see how they did it. They first said the opposite of that is that. We took care of that as we went. We don't have to do a separate line, but if that helps you, do it, okay? And then again, leave a space for any missing terms, and then write in the opposite of the second term. Okay? And there you have it. Same answer. Y'all are good. Okay. Now,
I'm going to back up one. And remember I said, in fact, I'll back up several, okay? Remember I said I really don't like this using add the opposite of the second term, second polynomial to the first. And here's why. What if this problem had said, and this is really dumb to me. They say add and then put a minus sign in there. That's not addition, that's a subtraction. So why did they put add? That they did it to confuse you. No, I'm sorry. I think it's just whoever did the slide. But what if the problem had been this? Subtract minus 8x squared plus 3x minus 4 from minus 3x squared minus 7. Is that the same problem or not? It is the same problem, okay? Because you're subtracting this from that. That's what you're doing, subtracting this from that, right? But this isn't the second one. This is the first one, you know? This is the one you change. So that's why I didn't like them saying change the sign of the second polynomial. That's the second polynomial because that's the one that's on the bottom. Do you remember way back in school? Now, maybe they don't do this anymore, but when I was in school, elementary grades, they named everything in everything. They had for adding, they were called add-ins, and then the answer was a sum. So for subtraction, it was a minuend, subtrahend, and difference. Yeah, some of you had those terms. Yeah, you had those terms. And you forgot them about in 3 minutes, right? Okay. But, say again? A little bit?
It was the same a little bit. Some stayed the same.
Some places do it, yeah. Okay. And in that sense, that would have been better to have names for them. You always change signs of the subtrahend. Whether it's first or second, you do it. Because this, you see, you're subtracting this from that, meaning you put this on the bottom. Okay? So, that's why I didn't like them to say, always change signs of the second term. Depends on how you write the problem, okay? So be careful for that. This one, you're subtracting that from that, so that one goes first, this one is second. Okay. And that was the end of that slide. Okay? Wasn't that fun? Okay. Whoops, wrong one. Okay. Discard. All right. Let's go to 10-2A. Oh, wait. I'm so sorry, people. I keep forgetting to look at the book. Okay. In the book, 10-1A was on page 2. And by the way, this is really neat. Each module starts over numbering. So when I say go to page number 2, you have to say in module number 10, go to page number 2. And then module 10-1B. Okay. I love this book. I'm loving it more every day. Okay. Am I being too sarcastic? Okay. Sorry about that. Okay. When you get your book, hopefully your ebooks will look something like this, but won't fall apart like this one is. Okay? Here's objective this. Oh, wait, I'm sorry. Here are your practice problems. And hopefully you'll have these on the ebooks when you got them. And they only give you 3. Okay? But they give you solutions on page S-4. Okay? Well, S, I believe, is the end of the module. Okay? Yes. That's where it is. So every module has an S-4. You have to be in the right module. So it's module 10 S-4. Okay. So do the practice problems. There's only 3 of them for 10A. For 10-1A. 10-1B, there's 3 more. Do those 3. Okay? So now we're ready for 10-2. I'll get used to this book one of these days, maybe. Okay? If I don't throw it out the window first. And by the way, this company Cengage,
they kind of thrust this book on and said, this is the one that's going to work best for you. And, you know, they said, okay, we'll go with it. And boy, now the more we've looked at it, the more I think everybody dislikes it. But anyway, you're stuck with it. You know what y'all are called? Guinea pigs, okay? We're trying this stuff out on you, okay? How does it feel? Squeak, squeak, okay. All right, we're still in Module 10, polynomials. In 10.2, Section 10.2, multiplication of monomials, okay? And do we know? Yes. Okay, they're called Objective 10.1a practice problems, and they were on Module 10, page 3, and Objective 10.1b practice problems on Module 10, page 4.
We're only doing the practice problems in section 10.1 and 10.2?
Yes. Practice, well, no, wait. 10.1a and 10.1b.
No practice problems?
Well, no, we're going to do these later. Yeah. But remember, each subdivision has practice problems. So do all your practice problems you can find anywhere. Okay. Now, okay, let me tell you what I've asked the guy to do. Whether he does it or not, I don't know. I've asked him to put on WebAssign some more homework exercises. I said, I don't care how many you put there, just put some. But I want you to have access to all of the tutorials, all of the aids and stuff. I sort of make fun of WebAssign. I really don't like it, but it does have some really nice features. Okay? So use WebAssign, and if he puts extra problems there, do the extra problems. Do as much practice as it takes for you to feel really confident you know what you're doing. I think all y'all are really good at this, so let's see. So 10.2, multiplication of monomials. How in the world do we multiply monomials? Okay, well, let's start with monomials. Okay. What would be equivalent to a monomial in a number? I know that's sort of a bizarre question. You were already here, weren't you? Yeah, okay. I was going to say we have to find a new desk for you. Okay. What would be equivalent with a number to a monomial is a digit. 7 times 4 equal 28. Okay? Same thing here. We're just going to multiply monomials. Now, what makes up a monomial? Someone remind me. I have a good memory. It's just real short. Okay? Numbers and variables and powers. Okay? That's all that's in a monomial. So guess what? We'll multiply the numbers, we'll multiply the variables, and we'll raise powers. That's what we're going to be doing. Okay? So let's see if that's what they tell us. Note that in the exponential expression x to the 5th, x is called the base, and 5 is called the exponent. Exactly. Okay? The exponent indicates the number of times the base is curved as a factor. What does x cubed mean? X times x times x. Okay? What does x squared mean? X times x. And if you're multiplying an x cubed times the x cubed, x squared, what would you get? X to the x times x times x times x times x. X to the 5th power. So what did we do? We kept the base and added the exponents. Oh, interesting. Okay? When you're multiplying multiplying expressions with the same base, different or even same exponents, keep the base, add the exponents. Okay? Now this is how I look at it. This is sort of the weird way my mind works. We have 3 levels. We have adding and subtracting on the bottom, multiplying and dividing on the next, and then exponentiation and roots up here. Okay? Now, when we're doing powers, okay, you keep the base, then you're multiplying the powers, the exponents go by, okay, you're multiplying powers, the exponents go by the thing underneath them. You add. And when you're dividing powers, you subtract the exponents. Okay? We'll get to that later. but not in polynomials. Okay, we'll get to that much later. So that's what we got here. So that would be keep the base, add the exponents. The product of an exponential expression with the same base, has to be the same base, can be simplified by writing each expression in factored form and writing the result as an exponent. Okay, if you want to do all that writing, it's perfectly okay. Okay. But the simple way to do it, and here's my definition of a good mathematician, or a characteristic of a good mathematician. I think they've got to be a little bit lazy. Because rather than doing this, they find an easier way. Keep the base, add the exponents. So, are any of you a little lazy? Oh my goodness, we have some buddy mathematicians in here. The rest of you hard workers, you can still do it. It's okay. All right to be a hard worker, but a little bit lazy, you're going to do well in math, I think. Okay, if you channel that laziness well. Okay, so that's the key. All right, so here's the rules for multiplying exponential expressions. Oh, they love putting letters rather than numbers, don't they? It makes so much more sense, doesn't it? Okay, m and n are any integers. Whoa! What's an integer? It's a number. Okay, that's the deal. An integer can't be negative. So now we're introducing something we hadn't dealt with before. I think what they should say here is positive integers, because we're dealing with polynomials. You know, this rule's still going to work whether they're positive or negative, but we're not dealing with negative integers as exponents yet. But if m and n are positive integers, you could say natural numbers or whole numbers, okay, then x to the nth times x to the nth is same base, different exponents, or even same exponent, keep the base, add the exponent. If this is a multiplication, drop down a level, add the exponents. Okay? So here's some examples. X to the 4 times x to the 7. X to the 11th. Y'all are good. X, or y times y to the 5th. Y to the 6th or 5th? 6. Okay. Well, I don't see an exponent there. Then you understand it be a 1. You're absolutely right. Okay. How about this one? Oh, 9, a to the 9th, because same base, 3 thing, 2 plus 6 plus 1 is 9, a to the 9th. Everybody see that? Did you see it? I'm sorry I'm blocking your view when I get over there, but they right on that side. See, if we're Jewish or Arabic, I could do it this way, but we're not, so I have to be right this way. Sorry. Everybody see that? Any questions? Any questions? Please, if you have questions, ask. Please. Okay? So, how in the world are we going to multiply monomials? I sort of gave you a hint before. They haven't talked about it, but hopefully you can do it. What do you reckon we're going to do first? Second? Okay, here's the problem. 2xy times 3x squared y. They gave you real simple examples. Now this is really more complicated, but it's not bad. So what would you do first? Deal with the coefficients, exactly. And what would that give you? Wait. I've got to get my pen back. Okay, what'd you get? 6. Now deal with the first variable. X's, what do you do here? X cubed, excellent. And then y squared, you got it. Okay? Now, if you don't want to do it, this is a lazy shortcut way. All right? She liked that, I could tell. Okay? Now, if you wanted to do it another way, you could do it this way. You could factor everything and make it 2 times x times y times 3 times x times y. Oh, this is fun, isn't it? Then multiply the numbers, 6. Multiply the x's, x 1, 2, 3, that's x cubed, and y 1, 2, y squared. You could do it that way, okay? And if you need to fall back on that, do it. By all means, I'd rather get a right answer, even if it took you longer, than to get a wrong answer you doing shortcuts, okay? But if you see the shortcut and it works and you got the right answer, go for it.
All right, let's see how they did it. That's going to be the interesting thing. Again, the first time I taught from this book, let's see how they do it. Well, they did it almost the same way I did. Well, they did sort of a hybrid. They took the numbers and did them first, 2 times 3. Then they took the x's and grouped those together. Because guess what? Multiplication is associative and commutative. Exactly. So you can change the order and you can change the arrangement. And that's what they did. They changed the orders and got the numbers in front. And got the x's together and got the y's together. That's the commutative nature of multiplication. And then they associated them like that too. So that would be 6 x cubed y squared. Just like we got, but y'all were much quicker. Well, they took another step, okay? They said 2 times 3 is 6, and then x, and we'll add the exponents, and then y, and we'll add those exponents. Yes? And that works too. And if it helps you see the answer, do it this way, okay? I want you to give me right answers. They're much easier to grade, and I'm lazy, remember? Okay, so I want right answers all the time. I don't want, so if it takes 7 steps, take 7 steps, okay? If you can do the Texas 2-step, do that, whatever, okay? Anyone, any questions? You okay with it? All right, good deal. Oh, and that's the end of that subsection, okay? Now, at the bottom of Module 10, page 5, you'll see Objective 2A practice problems. There's 4 of those, okay? Now, if some of you don't have books and you're worried about getting behind or something, if you want to come up and take pictures of these things, you can. I know you all have cell phones that will take pictures. You can certainly do that. And you've got a book, don't you? Huh? Did you pay your $8 and get that, or how did you do it? Huh?
I rented it offline.
Oh, I see. Okay. Well, then take pictures of her too. Okay. Okay. All right. That's 10-2A, practice problems. All right. Now we go through and do this again. I just enjoy doing this so much. Okay. What's that?
The question you're asking us to do, is that for practice, or we turn that in?
Okay. Good question. These things that I'm giving you for homework, for practice, okay, that's mostly what they are in practice. But if you can't get the answers, and by the way, the solutions are in that S section at the end of the module, okay? And even after looking at that, say, it doesn't make any sense. Then give them to me, turn them in to me, and we'll go through them together. Yeah, exactly. Exactly. And even if you say, oh, I got this answer, but I'm not sure how I got it, I can see, yeah, I got it. Yeah, anything you have questions about. I'm sorry, we're just feeling our way through. Remember, squeak a lot. You're guinea pigs, okay? All right. So now we move on to Module 10, sorry about that. And we're now going to do Section 10.2, Multiplication of Monomials. But this time, 2B is Simplify Powers of Monomials. My goodness, did they drag this out? Okay. A power of a monomial can be simplified by rewriting the expression in factored form and then using the rule for multiplying exponential expressions. It's almost the same thing. Now they're doing a power of a power. Well, what does it mean? What does it mean? Anything. I'm sorry, I'm blocking the review. Anything cubed. What does that mean? Multiplied by itself 3 times. So this would be x squared times x squared times x squared. And then that's x, 2 plus 2 plus 2 is 3. So you can do it that way. You certainly can. But for us lazy people, there's got to be an easier way. I don't have to take that many steps. What can we do? When you're raising a power to a power, now you're up here on level 3, drop down to level 2, and multiply the exponents. And is that what you just did? 2 times 3 is 6. Yes, that's what we did. Okay? Note that multiplying each exponent inside the parentheses by the exponent outside gives the same result. Hey, I'm nice and lazy. I like that method better. But this works. It certainly does. Write it out, add them together, you get it. You get it done.
Okay? Does that make sense? All right. So, the rules for simplifying powers of exponential expressions. If m and n are any integers, now again, we're not dealing with negative integers, and integers can be negative, so they should say are positive integers. But this rule still works if they're negative, but you know, x to the m raised to the n power is the same as x to the m times n. If you're multiplying same base, different exponents, keep the base, add the exponents. If you're raising a power to a power, then keep the base, multiply the exponents. In each example below is a power of exponential of that. We're just going to do it. Okay, what would that be? X to the 5th squared. X to the 10th. Y'all are good. How about y to the, I'm sorry, y cubed to the 4th. Y to the 12th. Y'all are so good. This is so easy. Sorry. I wish I could make it harder. I've tried, but I can't think of any way to make it any more difficult. Okay? Any questions? Okay. Well, here's some more rules. What if m, n, and p are all integers, so we're going to presume that they're positive integers, then x to the m, y to the n, both raised in parentheses to the pth power, what would that be? Okay, XMP, which is military police, never mind. Okay, y to the NP would be that. And basically, you're just separating them, doing them separate. Do this that way, do that way. Exactly. Yes, question? Oh, okay. In each example below, let's see if we can do those. What is c to the 5th, d to the 3rd, to the 6th power? C to the 30th, d to the 18th. You're reading my fingers, aren't you? Okay, never mind. Okay. All right, I'm going to get down here. No, don't look. Okay, all right. Okay, 3, 8 squared, b, all cubed. 27, excellent. Remember the 3 you have to cube. That's 3 cubed is 27. There it is. A to the 6th, B to the 3rd. Perfect. Y'all are good. Any questions? Now, if you have questions, ask. Want me to go back and show it? Okay? Does that make sense? You're cubing this one, cubing that one, and cubing that one. And separate them. Do them individually. Okay? And then bring it together. Does that make sense? Got it? All right. Any questions? I know this is it's inching up on it. You've heard that story of the frog in the pail of water, and you put a fire under it, and it never notices it's getting hotter until it boils. Okay? Whereas you drop a frog into the hot water, it's going to jump right out. Okay? So we're inching forward, making it a little more difficult each time, and don't get suddenly find you're fried or something. Okay? So let's go and do it. All right. Let's do an example. You tell me what we do here. Oh my. Let's take as many steps as you need. Tell you what I'm going to do. Boy, all their early examples are so easy. Then they throw this mess at you. Let's leave this. Let me get my pen back. I keep forgetting. Minus 2x. Let's just leave that alone. That's so simple to begin with. Let's deal with the second part. What will we do with that? Okay. It's what I heard. Negative 3 cubed. Is that what you said? Okay, that sounds like a good plan. Times x cubed. That sounds like a good plan. Times y squared cubed, which is going to be y6. Perfect. Okay, she's cheating. Go ahead. So let's leave this minus 2x alone for now. What is negative 3 cubed? First thing I want to do is deal with the sign. What's the rule on the signs? Say again? if you're raising a signed number, just deal with numbers, to a power, if that power is even, the answer is going to be positive. If that power is odd, it's going to stay negative. What if that was a positive number raised to an even power? Everything's positive. The positive number raised to any power is going to be positive. It's only the negative numbers, and if you raise it to an even power, it goes back to being positive. The odd power stays negative. So this is going to be a what? Negative 27. Okay? Then what's next? X cubed and y6. Okay, she was already there. Okay, now, again, count your number of signs. How many minus signs? How many minus signs you got? 2. And what does that mean? Positive. This is an odd number of minus signs. It's going to be negative. Even number, it's going to be positive. So it's going to be a 2. Multiply your numerical parts. What does that give you? 54. And then x to the 4th, because you have 1x here and 3 there. That makes x to the 4th. Y to the 6th. Hey, y'all are good. Okay? Let's see if they got it right. Okay? They may have missed it. Let's see. All right. They got a negative 2x times, and they wrote the problem again. I'm glad they did. That was really productive. Then they did minus 2x, just like we did, separate that. Then separate those out individually, minus 3 cubed, x cubed, y6. They went just like she did back there. Went on and figured out what that one is. Then they combined and did a positive. Oh, no, they didn't. They first raised the negative 3 to the cube power, third power, and that gave you minus 27. So that gave them a minus 2 times a minus 27. I'm glad they took all these steps. Then an x times an x cubed. And if this helps you see the answers, do it. Do it by all means, okay? And then y6 is all there by itself, poor thing. And that gives you a positive 54, x to the 4th, y to the 6th. Perfect. Does that make sense? There's several ways you can approach these problems. As long as you do every step correctly, you got it knocked. How do you eat a 5,000-pound elephant? One bite at a time. So just break it down, take the little pieces that you know, put them together. Finally, you'll be bloated, but you'll be finished. Okay, good deal. Any questions? All right, that's the end of 10-2B. And on module 10, page 7, there are 5 practice problems there. Do all 5 of those. They are fun. Okay? All right. Okay, we got 3 minutes. I think we can get 4 more modules done, can't we? Okay, let's see. Let's get out of that one and go to 10-3A. Let's at least get started here. All right. Slideshow. Current slide. We're still in Module 10, polynomials. And we're still in 10-3, multiplication of polynomials. No, this is a new one, isn't it? Okay. What's different from this from the last module? The other one was multiplication of monomials. Now we're going to do polynomials. So now my question to you is, what would multiplying polynomials be equivalent to in numbers? Remember, your multiplying monomials are like multiplying digits together. So this would be like multiplying big numbers. Give me a big number. 400 what? Say again? Okay. Y'all want to do something with this guy? Okay, no. Give me a number. 4,000. 4,000. More digits.
Okay, 4,686.
86?
Yeah.
Okay, I like it. And let's multiply that by another big number. Smaller, but bigger. 2 digits.
2 digits?
Yeah, 2 digits.
Okay.
Say again?
48.
Huh? Someone said something. 2 Two-digit number. Hurry, hurry, hurry.
48.
45? Okay, whatever. Okay, 45. Now, how do you multiply those together? One digit at a time, don't you? You do 5 times 6 is 30. You carry a 3. And then you do 5 times 8, which is really 5 times 80, isn't it? And that would be 40, which would really be 400. But you add 30 to it because that's over the 2. That would be 3, carry a 4. So you're doing one digit at a time, right? And then 5 times 6 is 30 plus 4 would be 34, carry a 3, 23. And then you skip over 1 and you're doing 40 times 6 would be 24, carry a 2. And that would be 8, 10. So you see what you're doing? You're multiplying one digit at a time, but then you're adding like digits. Your ones, your tens, your hundreds, your thousands, your 10,000s, and stuff like that. You're multiplying a digit at a time, but keeping the power. That's exactly how we're going to do polynomials. You're going to have many terms, multiply one term at a time, but keep up with them, and then come back and add like terms. That's what we're going to do. We're going to do it next time. Okay, you got your homework exercises? We'll pick up here at 10:1. Sorry, we should have gotten further, but we'll see. Okay? Good deal. Good deal. Thank you. Okay, how do y'all feel? Is this going too fast, too slow? Okay? Huh? I'm sorry? Oh, okay. If you don't, you're in big trouble. Okay, no, okay. Okay. I'm sorry?
What did I miss last week? What is that?
Oh, these are paper topics. Remember I said there's a research paper? Okay. If you read those instructions that are out there under class handouts and more, it says try to get me a paper topic this week and next. Okay, and if you listen to it once I get the YouTube video, you'll hear me talk about it in gory detail, just like I do here. Okay. How is this going? Is this too fast, too slow, or okay?
I learned this in
Huh?
high school. So
Yeah. Okay. Good. Sorry, it'll pick up a little bit. Huh?
Is this book in the bookstore?
I don't know that. I think no. She said she bought it elsewhere. Yeah. But the thing is, the way they're doing it now, you have to do the Cengage online, and huh? Oh, okay. Oh, you don't have to, but if you want to, you can. Here's pens or pencils, whatever. And once you pay the Cengage online, then you get an ebook, and then once you got the ebook, you can get a paper copy from there for like $8. But if you buy it outright, it's going to be probably more than the Cengage online would be.
Yeah, I think online's like $119.
It's what?
$119.
$119 gives you all the books that you would use in Cengage that term. Yes.
Get your book.
What's that?
We're not able to get your book online, but I need your code to get it.
I know, but they haven't given me the code
I'm
yet.
saying
Yeah.
I can't get it. So.
Yeah, until then.
That's kind of
But anyone who wants to take a picture of the problems or anything, you certainly can. I'll show you where they are. Let me put something in place here. Okay, that's going to be the last one. And go back. Okay. First, second, third, and fourth. Okay. So, area. Let me turn it around for you.
And also, sometime in October, because I have my baby in October.
Oh, okay.
So, how are we going to do that?
Okay.
They told me something about the
Okay. Remember, I'm recording everything. You'll be able to follow everything from home.
Yeah, but I don't want to be absent. Like,
I know. Okay, well, any day that you can't be here, you can follow it there. But yeah, you can be here as much as you can. I encourage you to do that. But don't put your life or the baby's health at risk, okay? That's, as believe it or not, a little more important than health. Okay? Not much, but a little bit.
You said this 1, 2, 3.
Yeah, these, what do they call them? Practices.
Okay.
So those, and then you go to the end of the next section, and there's those.
Are you taking pictures too?
I'm going to. You go finish. I've got like math tutoring after this or something. So.
Mine not until Friday. So weird. You would think it's after this like, class, but it's not.
first. So when you find the objective, right above it is the,
Okay. So
Yeah.
this is the problem.
those are the problems. I think the whole book's the problem. No, I didn't.
Yes,
say
it
that.
is.
Right. You seem pretty sharp at this stuff.
Been in college. Let's see. I've been in college for 15 years. I hope I got something out of it.
Yes. Well, I bet you it's moving a bit too slowly for you, right?
Actually, I enjoy this pace because it gives me time to deal with my biology, which
Oh,
I'm
okay.
just about to go crazy. I hate biology
Why are you taking it?
because I'm a nursing student.
Okay, yes, I was going to say, if
I've
you're
already
a nurse.
failed it once. Well, I didn't fail. I dropped it.
Yeah.
No, this one ain't much better.
Is this anatomy and physiology or just a human biology?
Anatomy and physiology.
Yeah.
And the teacher I have is like, oh, it's all online. Figure it out.
Yeah. You know, you seem to have such a good mathematical. Why am I recording all our